Welcome to Logic Bits. I am Vinod Kumar. In this video, we will discuss multiple inheritance in Python programming language. What is the definition of multiple inheritance? A simple definition of multiple inheritance is a single subclass having multiple superclasses. In Python, a subclass can have any number of superclasses. Physically, there is no limitation. Now we will move on to the syntax of multiple inheritance. Syntax of multiple inheritance. Class is a keyword. Class is a mandatory keyword followed by name of the subclass. Within a pair of parentheses, we have to mention the name of the superclasses. It is a comma separated list. We can have any number of superclasses. These attributes and methods belongs to the subclass. The subclass may or may not contain attributes and methods. If the subclass doesn't contain attributes and methods, simply use the pass keyword. Means the class is empty. The class is acting as a placeholder. At a later date, we can add attributes or methods. Now we can move on to the example program. In this example program, we are using two superclasses SUP1 and SUP2. In SUP1, we are using an attribute called A. It contains the value 6. In SUP2, we are using an attribute called A. It contains the value 7. That is, the attributes are identical. The names of the attributes are identical, but the values are different. In SUP1, the value is 6. In SUP2, the value is 7. Here we are declaring the subclass. The subclass having two superclasses. Within a pair of parentheses, we have to mention the name of the superclasses. It is a comma separated list. SUP1, SUP1 and SUP2 are the superclasses. So inside the subclass, we are using a single attribute and we are using a single method. The subclass contains one attribute and one method. For the subclass, we are creating an object. By using this object, we are calling the add method. So what will happen? The control will be transferred to this point. C is a local attribute, belongs to the add method. B contains the value 4. B contains the value 4. But in the case of A, there is ambiguity. There is repetition because in this place there are multiple copies of the attribute A are available. There are two copies of attribute A are available in this place. One belongs to SUP1, another belongs to SUP2. So the Python interpreter will consider which value. Here there will be a confusion. To avoid this confusion, we will use the order of derivation. To avoid this confusion, to avoid the ambiguity, to overcome this problem, we are using the order of derivation. What is the order of derivation? SUP1 followed by SUP2. So in this case, SUP1 appeared in the first position. SUP2 appeared in the second position. Whichever class appeared in the first position will get more priority, will get more importance. So, in this case, the value available in SUP1 will be considered for this expression. So, what is the value of A? In this case, it is 6. So, 6 plus 4, it is 10. Finally, by using the print statement, we will print the value in the output. We can run the program. Go to the run menu, run module. So the addition is 10. Now we can go back to the program. Now I will change the order of derivation. SUP2 followed by SUP1. Save the program. Now SUP2 followed by SUP1. So what will happen? In the order of derivation, the first class is SUP2. So SUP2 will get more priority than SUP1. So the value available in SUP2 will be used in the expression. So here the value of A is 7. 7 plus 4, the result is 11. Save the program. Run the program. Now the answer is 11. That's all for now. For more videos, please subscribe to LogicBits channel. Thanks for your patient listening. We will meet in the next video. Thank you.